So these are the take-home points. You're going to see more of that as we go on. So one of the difficulties you're going to have right now, put the in-class assignment away. One of the difficulties you might have right now is not taking notes. I've seen it before. So what I've seen students do is just try to take notes because that's what they feel comfortable with, and they slowly get used to it. If that's what you feel comfortable with, go ahead. But if you trust me, don't take notes, just listen. And then ask questions because those questions come on the video too. Okay, so the take-home point of this assignment, which we're not quite done with yet, is that the pediatric growth charts do not have constant slope. The slope is the speed. This is a different way to introduce slope. I've been in classes, I've taught them before, where I start out with y2 minus y1 over x2 minus x1. And, you know, everybody's eyes are glazed, they're sleeping, and I think maybe I should record myself and use it as a lullaby for my kids. It's not really doing anything, but that's what it is how fast or slow something's growing. And what's nice about this class is the x-axis is usually time now, so it has a relevant thing. It's not just x and y, they actually have meaning. Lines do have constant slope. What's really nice about that as we continue on that in-class assignment on Monday is you're going to find that this is how you give estimates. You should expect to see a pound per year of growth, or you should expect to see this many inches. These are the kind of rates that you can give out, and we're going to see what the limitations of that are also on Monday. What this class is about is we would like a way to talk about growth that changes speeds, and lines don't do that. So that's what calculus is about. You know, my son asked me what calculus is about. That's what it is. You know, your car's going fast sometimes, and then you see cop and it slows sometimes, and then you get to Montclair's campus and you're going fast, and you're like, wait a minute, it's 25 miles an hour. I saw someone get caught yesterday. So you slow down. So your speed is changing over that trip that you're taking. We would like a way to mathematically analyze those changing speeds and what they mean. In medicine, it often is about knowing what those speeds are and finding those deviations. How does someone with cystic fibrosis change? How do their metabolic rates, it's a rate, change in comparison to someone who's healthy? If someone's an outlier on a curve, I can identify them as being a deviant in some way and something's wrong. It's a way that you can flag things down. In fact, we're doing that in pregnancy. In pregnancy right now, you can only find complications by the second or third trimester. I was funded last semester to look at early pregnancy, where we can actually do something about it using mathematics. If I have a predicted curve and someone's not on the predictive curve early, I know something's wrong. And that's all about rates. So I'm using calculus to do that. So this is calculus. So we're done. No, sorry. Slopes that change with time. That's what it is. And you get the machinery. So we're going to get into some of the machinery, but to do that, you have to go over some pre-calc, which I usually don't do, but I'm going to do it because someone already told me that they didn't take, I asked them, why are they taking this class now when I had them last year? They should have taken it back to back. So it gave me the insight to ask you that question on your inspo sheet. So a little refresher. And if you need more of a refresher, on the playlist, there's a class called pre-calc. Just go up in there and look at the module. They're all labeled, so you can go back and look at any topic you want. And it's me. It's not someone else. So I didn't really talk about these a lot in pre-calc. I focused on other things, but they want you to get familiar with shifting graphs. And I looked at the test questions that are asked by my colleagues, and they asked this. So this is 2 reasons I'm giving it to you. Sometimes it's all fun and games, and sometimes it is about taking a test. So this might be a test question. What do you do if you have a graph, y equals f of x, and you look at another graph and it's +9? So I'm going to show you the approach so that you can handle any problem. I know this one's a little easy, but what I would suggest you do is you make a table of a test function and actually see. And I chose y equals x minus 1 squared as my test function. The reason is it's not a line. Y equals x is a line. And x minus 1, make sure it's not centered at 0. So if it's centered at 0 and everything is changing around it, I might not be able to see that change properly. So I scooted that away from 0. And I just plotted it just to see. If you're not familiar with these graphs, you have a handheld calculator, just graph it. If you're at your desk at home, there's much better stuff on your computer. So I actually don't like the TIs. I think they're also they have no motivation to make it nicer. There's nicer ones on your calculator, on your cell phone that you can just get for free downloads that outperform your graphing calculator. But I've not seen those graphing calculators, tiny little monitors. I've not seen them change. No motivation to change it. There's no reason. There's no market for it. Now here's what I mean by just make a table. Take your test function, and when you choose some numbers, make sure that you choose some numbers that are plus or minus around it. And then just calculate the y in your test function. So I have that. And then just add 9 to it and see what the difference is. And what I see is, see how nice that is? That would take me out 20 minutes just to work that out. So see that? It's just scooted the y values up. Y is your elevator that goes up and down. So the yellow is 9 higher than the original. So in the elevator, they're 9 floors higher. So it's the same graph, except 9 floors higher. So I just look at the numbers to make that determination. And I know this was an easy one, but I wanted you to see my strategy. I'm not going to give you something to memorize. I want to give you something that you can use. So if I throw anything at you, you can figure it out in a very simple way. And this is the simple way to figure that out. So what I conclude, all y values were raised by 9 in my yellow. So my entire new graph is 9 higher than old. So I'm giving it to you numerically. And then I used a program called Maple. Like I said, I hate those little monitors that you have on your graphing calculator. I just really can't stand looking at that thing. Look how nice it is. I can actually see the colors and everything. So I can easily tell it to graph it. And you can actually go online. I see my son using web tools to do things like that. He even uses web tools to do algebra now. So everything's online for you that you can use that's going to give you a better picture when you're sitting with your website. It won't really help you when you're on your test because you don't have those tools with you, but that's where you use your graphing calculator. And we'll often use it in class to get familiar with how to punch these things in. So you can use that for the little monitor that you have there to figure something out. So the green was the original, and all my graphs, the green is going to be the original. And you see that the new graph, which is the red one, is exactly 9 elevator floors higher than the original. So that's what it does to the graph. And in Webassign, you have a little thing that shows you, I think you have to tell it it's 9 floors higher or something. It has a little prompt that allows you to do that. So this is the first problem that you have on Webassign. I'm giving you a sample. So when you sit down to do your homework, you just look at the videos, and I think it works that way. Does it work that way well? Yeah. We didn't have it for grade, so I can see it. So I actually go backward because I'm visual, so I can see it. I actually draw the graph, and I just look and see if I can figure it out from there. But if you can't, then you make the table and figure it out from there. So now they have f of x plus 9. I actually remember getting these kind of questions when I was a kid and trying to figure them out. And I would try to memorize it. Say, oh, this one shifts at left, and this one shifts at right. And inadvertently, no doubt about it, I would get that 50% chance. I'm always choosing the wrong thing. And then I would get 0 points. So table method works really nice. So let's see what happens. I'm not seeing it. I punched in. What I did is I replaced the x with x plus 9 there. That's what it says to do. It says take x and replace it with x plus 9. And I just shifted it, and I got really big numbers. And so I'm not seeing a pattern going from here to here. So I changed my strategy. What I did is, instead of looking at the original x values that I had put here, I looked back at how I would get those same numbers, what I would have to do to the x values to get the same y values I had here. And I realized that if I plugged in -11 in for x, I could get 9 as my answer. And if I plugged in -10 in for my x, I could get 4 as my answer. So I started trying to think strategically of what this is doing. And I knew a little bit. I remembered, it shifts something. So, and the x direction. So maybe I'll put in some numbers in there just to see where it shifts to. And so it tells me that which direction will my graph shift, just based on this data I have here. Left, right? Because all these numbers are to the left of the original x values. So I get the same y values if I just take all the numbers and shift them left by how much? 9. Okay, so you can also see this by graphing. See that? Yep. Indeed. The original is green, and the new graph is shifted 9 to the left. So you won't get that left-right thing wrong if you do this with tables. And I'm looking at it, some of you are nodding your head, so you've done it too. You put right, because you saw +9. And then Professor marked it all wrong. Don't do the 50-50 chance. It never works out good. With anything, you know. I think this guy might be a 50-50 chance. Don't do that. Not a good idea. All right, so here we have 9 times f of x. Well, this is kind of obvious what's going to happen. If I do 9 times the original numbers, they're just going to be larger, right? 9 times larger. If they're 9 times larger, it'll take my original graph and make it much steeper looking, right? Because they're going to be huge. It's like the elevator's going shooting up so fast. So I see that also when I graph it. The original graph is 9 times steeper, 9 times faster it's going up. And I do see that. If I graph the original with the new graph, I see that it's 9 times steeper. You get a squished graph. I can't remember what they want you to put in Webassign because I don't have the answers in front of me, but I remember that it was obvious what you're supposed to put there after you see this. Okay, some of them are not as obvious, but these original ones were obvious. So if you struggle at that point, you can always shoot me an email. What about 9 times x? What does that do? Well, this time I'm going to be smart about it. I'm going to first replace the x with a 9x, and I see that I get some huge numbers, but I get the 1 matching up, right, with the zeros here. But none of the others seem to match up. It seems a lot steeper again in the x direction. One thing to note is that when I get x equals 1/9 gives me the 0, where I used to have a 0 at x equals 1. So it's like the graph has shrunk, right? I'm squishing everything. I used to have a big window, and now I have a small window. It's what you do with your phone, right? It's exactly the same thing. That it's a scaling. There was an image guy that interviewed here, and he showed us that's what they do. They have a transformation in there that scales it, so you go 9 times x, and it goes like this. That's when your fingers go like that. There's a math formula in there that's doing that. It's exactly what it's doing. So the graph is squished. Squished is a mathematical word. There it is. The original graph is squished, and the zeros changed over. I can see that. Again, on Webassign, my recollection is that it was obvious what I'm supposed to put. I think it might have been a drop-down box that you have to put something, but it was obvious what I had to put. What about this one? They've got 2 things going on. So I did it in 2 steps. I first took this, and I just took the minus f of x part. So I put it in the minus f of x part. It just makes everything negative. So if it was elevator was going up before, now where is it going? It's going down, right? So the new graph has everything below the x-axis, and the original graph had everything above the x-axis. So it's the original graph, but reflected, right? The same thing, but going down. And what does the -1 do?
Down.
And you can see that with the numbers. So let me just show you what I meant by what used to be up now is down. What used to be a y value that was 9 is now -9. So you see exactly that. Instead of the elevator going up, the elevator is going down. And now I'm going to shove that down 1 more by -1. You can see that the numbers turn out to be -10, -5, so they're 1 more down. So it's the original graph tipped upside down and scooted down by 1. These are very technical words. Oh, look, I used real math words instead of scooted down. Reflected over y equals 0 and down 1 more. There it is. I can see it. So you don't have to do the table. You can actually do the graphs first. If you see it from there, an answer, then you're fine. I'm just showing you everything so that when you're doing your homework problem, if just graphing it doesn't work, you can go back to the table method to figure out what the numbers are doing. This one was tricky because you got 2 things going. You have the 9 on the outside and then 1/9 on the inside. So I'm going to start with the inside first. What does that 1/9 do? Now I'm getting smarter about this. I'm going to replace the x with 1/9 x. So that's what it says to do. That when they have f of 1/9 x, it means replace the x with a 1/9 x. But I'm going to make a little chart inside here. So remember when I messed with the x? it always changed the y values drastically and I couldn't see what was going on. So this time I'm going to choose the y's, the x's, so that the y's come out as before, because it's doing something on horizontally, right? It's not doing something with the elevator, it's doing something with the walking around on the floor. So I'm choosing my x's so that I get the same y value out. So what has it done? To be on the same floor in the elevator, where would I have to walk to? At -2, instead of starting at -2 to get a 9, I would have to walk all the way over to 36. So what's it doing to the graph? Widening it, right? It's widening it up, opening it up. It's much farther out. So to get to that same point on the elevator on the y-axis, I'd have to walk much farther down the x-axis to make that happen. So I would expect to see a fat graph. That's the 1/9 doing its business. Super widens the original curve, right? 36 is a lot farther down the road than -9. What does the 9 do to those numbers? Well, it makes them really large. So super widens it first, and then it squishes it next, right? Because it makes it a lot steeper, like we did before. Not multiplying by 9 made it higher. The elevator went higher. So I did this in pieces. The blue is the green is the original, the red is the fattening, and the blue is the final version. So I don't remember how they asked you this on Webassign, what you're supposed to answer, but I'll give you my phone number a lot so that you can text me if you see the problem, because I don't remember honestly how they prompted you for the answer on this. I don't know if they did it in 2 steps or if they asked you what happens. There's a 2-step process. It fattens it up first, that's the red, and then it squishes it next. That's the blue. Okay, any questions? That was pre-calc, explained super fast. But you can stop me and pause me and rewind me. That's going to be the nice thing.